Hi guys, this is a quick tutorial on how to use Excel to complete your experimental probability simulations. Now the example I'm going through here is quite a simple example where all of your outcomes have the same probability of happening. So for example, if I had 12 pins and I throw a hoop 3 times and I land on 3 pins, out of those 12 pins, 4 of them are worth 1 point, 4 of them are worth 2 points, and 4 of them are worth 3 points. So there's an equal chance of me getting a 1, a 2, or a 3. Now in your tree diagram, you should have already worked out the total possible scores after 3 throws. So if I were to get 3 ones in a row, I could get 3 threes in a row, I could get 9, and these are all of the other possible options that could happen. You would have then worked out the probability of each of those scores happening in your tree diagram, remembering that number of favorable outcomes divided by the total number of outcomes. That's the theoretical probability that you should have already completed. What we're going to do now is use Excel to run the experimental probability simulation. All that is randomly generating a number between 1 and 3 for each of our throws. Looking at this table here, we're going to have 20 different people play our game. They're going to throw a hoop and they're either going to get a 1, a 2, or a 3. Now because it's an even chance of each of them happening, it's quite straightforward. All we do is we click on throw 1, player 1, we write equals rand between, and the range of numbers is between 1 and 3. So equals rand between 1, 3. Now we have our first result. Player 1, their first throw was a 3. We move down to the corner, it turns into a black cross, and we drag it down. Now we have everyone's first throw. Those 20 people, here are their first throws. We then drag that across to get all 3 of their throws. Now you'll notice that that first column is already changed, so what we need to do to stop it from changing is copy and then click on that first box again and paste 1, 2, 3. That is going to lock everything in place. So now we have all of the results for our 20 people. We now need to work out what are their total scores. So for player 1, their total score is equals sum to add them all up, and we highlight their throw 1, throw 2, throw 3. We end up with a total of 4. We then click on that, move to the corner, drag it all the way down, and now we have their score for all 20 people from 4, 5, 6, 7, 8, 9, etc. Now what we need to do is figure out how many of these people actually won. Now based on your tree diagram, you should have already chosen a score that you think would be a good winning score. So for me, I'm just going to choose 4. If you get a score of 4, you win. I've just chosen that from random. You should have already had an idea of what you want. What we need to do now is then get Excel to count up how many people got a 4, so how many people won. And you can just go through and count it individually, but what we need to do is use a specific formula. And the formula we use is equals count ifs. What that does is it literally counts if someone got a 4. Every time someone gets a 4, it just counts it. So equals count ifs, bracket, we highlight the total scores that we're looking at, and then we click comma. For me, I'm looking for 4s. I'm just going to write the number 4. Enter. And it's shown me straight away 4 people scored 4. 1, 2, 3, and 4. So my number of wins was 4. The number of trials that I completed was 20. Now 20 is a good number because it's not too many, it's not too few, it's pretty much just right. You could, if you wanted to, make it 30 trials or 40 trials, so that's going to be quite a large table. So 4 people won out of my 20. Remembering my probability formula, number of favorable is 4, divide by the total number, which is 20. So my probability of winning is going to be equals 4, divide by 20, and my 20 was in my N5 box. So I'm going to write N5. So there's a 0.2 chance of winning. We just need to convert that into a percentage. So 0.2 times, we use our asterisk, 100. And so there's a 20% chance of winning by getting a 4, based on this experiment that I've just run. Now your score may not have been 4. You could have chosen 5 or 6 or 9. Or what some of you chose was a combination of 2 different scores. So if you score a 5 or a 6, you win. And there is a way to do that as well. So instead of a 4, let's make it a 4 or a 5. The way we do that, we go back into our formula here, count ifs. At the moment, we already have a 4. We want to work out the probability of getting a 5 as well. So we just go plus count ifs. And we do the exact same thing, highlight our numbers, and instead of a 4, this time we're writing 5. And what that's going to do is count up how many people got a 4 or a 5. And Excel is telling us that 10 people got a 4 or a 5. 10 people out of 20 is going to be 50%. So based on this trial, if I made my winning score 4 or 5, then 50% of people would win. And that's not really ideal. Just remember though, this result here, 50%, is based on 20 people doing it. When you did your tree diagram, you would have found a theoretical probability. What you need to make sure is that your experimental probability matches your theoretical probability that you did in your tree diagram, which should be close to your target probability that you were told for this assignment. So you need to design a game with a 28% chance of winning. Based on this, there's a 50% chance, so that's not ideal. What you can do is completely run this experiment again. So we start from scratch. We delete it all, and we start again. Equals rand between 1, 3. And we repeat that process one more time, drag it all the way down, drag it across, copy, and lock it in. And then we have a new percentage. With a score of 4 or 5, we had 8 people, which was 40%. So now we have a 40% chance of winning. Maybe that's closer to your target probability. But what you need to do is replicate this a few different times until you get the probability that you want, or alternatively, you could change your target score to a 6 or a 5. But you would only change that if it matches what your tree diagram is saying. So if you've worked out that the best probability is to get a 6, then you need to run your experiment until your probability shows that a 6 is the best score. Once you've done that, you just highlight your spreadsheet, paste it into your solve section, and hopefully it matches up with your theoretical probability. That should hopefully be enough to get you started. If you have any more questions, definitely let me know.